Welcome to Zell Engineering YouTube channel. Today I will show you how to model, analysis, design and preparations of structural drawing for flat slab in 3 tutorial parts. The first two tutorial parts, that is tutorial part 1 and 2, is all about model, analysis and design. From these two tutorial parts, that is tutorial part and 1, we are going to fix depths of flat slab using error code, and we are going to fix also dimension and depths of drop panel at columns. The last tutorial, that is tutorial part 3, it is all about detailing of structural drawing in AutoCAD software. I will show all these design principles both in finite element and step method. Watch this video up to the end, since the last point that I have told to you is a game changer, or it's very important. Thank you for subscribing my channel to get daily updated videos on complete structural design, construction techniques, and how to prepare a priced bill of quantity. Let's dive into this practical tutorial. Our project is 8-story mixed-use building. So my client needs a flat slab on a first floor slab. So we are going to design together this flat slab. In the previous tutorial parts, I'm going to show you all about how to model a building and how to define all the load patterns and how to combine load combinations. So you can go back to my previous tutorial, that is from tutorial 1 up to tutorial 7, and you can check all the tutorial that are more about how to assign loads, how to combine loads, how to define loads, and all about modeling of complicated building projects. So you can go back and check all these tutorial parts. But in our case, to design this flat slab, first of all, I'm going to analyze this model, and I'm going to approve that all the frame are passing the designs. After that, I'm going to export this flat slab into CSI Safe version 21 software, and I'm going to design all things here in Safe version 21 software. So first, it's better to before exporting this flat slab model, it's better to go to analyze your model. So to do this, it's better to go to analyze and check that all the frame pass the design. The ETAP software is going to analyze the model using all the assigned load combinations. The load combination includes the quick load, all vertical load, wind load, etc. So the analysis is completed like this. After that, it's better to go to design. So concrete frame design. From this, it's better to select your building code of standard with this constant parameter, that is error code. After that, you must check that all the load combinations are selected here. All the load combinations are selected here. After checking that, make it okay. After that, you can proceed to start analysis and check. Now the software is going to analyze your frame. It takes some time, so it's better to wait. So the horizontal frame is analyzed and it's passed to the vertical one. So all the analysis is completed. After this, the software gives me all the reinforcements to the frame and the section sizes. After that, it's better to go to design again, concrete frame design. It's better to check that is all member passed the design. So you can go to this menu and verify all members passed. All concrete frame passed the design check. That is good. After this, you can proceed to exporting your flat slab. So unlock your model. After that, I'm going to export my flat slab into Safe version 21 software that is more applicable to foundation design and horizontal structural member design. So to do this, it's better to go to File. After that, export story as SF F2K file. After this, I'm going to export the first story. So I will select first story. From this menu, I'm going to export floor loads only. This is because I'm going to design the floor only. But if you are going to design your foundation, you can use this two choices to design your foundation. The first choice, that is export floor loads and load from the above. This is for foundation design that is not considering temperature load. If you are volunteer to consider, or if considering a temperature load is a mandatory, you can use this choice. After that, the next point that I've told to you is load case and load combination to export. So you have to select this all your load combinations and load cases. So you must choose that selecting all this load case and load combination menu. After that, you are going to export your data, so you make it okay. After this, it's better to go to save your data as a flat slab design. From here, I have to name my project as first the client name, that is Lydia, and the project is basement plus ground plus 5. So you have to put your project's floor height or story. After that, the purpose of your project, that is a mixed. So Lydia basement plus ground plus 5 mixed flat slab design. Sorry, flat slab design 1. So make it okay. After this, your data or your all your data from ETAP software is exported to safe software. So you have to go to safe, open safe software. After that, go to file, import, save F2K text file. From here, I have to going to select my data, that is Lydia basement plus ground plus 5 mixed flat slab data in one. This is my exported data. Open it. From this first floor flat slab is appeared on safe software like this. I will show it on ETABS software. Go to first. That means this slab. It's similar with this. So after this, all the data from ETABS is exported to safe software. So I'm going to design my flat slab on safe software. So I will check all the data. That is, go to define menu. After this, I'm going to check all the load patterns that we are going to define from ETABS software, and all the load combination. All 42 load combination is appeared from here. So it's better to check also all assigned loads. To do this, go to display. So show load assigned. So from here, I will going to select a shelf. Then I'm going to check my partition wall loads. Apply. From this, all the load that we are going to assigned as a partition wall load is appeared like this, and I'm going to check also all the floor finish loads that we are going to assign. It's appeared like this also. So all the datas, for example, the live load, all the datas are exported safely. So using all this data, we are going to analyze and design my flat slab. Before going to analyze and design this slab, it's better to go to draw all the strips. That is to use a design strip or strip method design. I'm going to assign all the column in the middle strips. So to do this, I have two choices. That is, first you can go to edit add design strips, add or edit design strips. So you can add or edit design strips using this menu. But the second choice is that go to draw. So using this draw design strips, you can draw all your design strip. For workmanship, I'm going to delete or cancel this. So go to draw design strips. From here, I'm going to draw a column strip, that is a column strip along layer A, that means to the X direction, and column strip along layer B, that is to the Y direction. So it's better to first draw the column strip to layer A, that means to X direction. From that, start with this left, that is from the center of the column. So you have to correct this data as 500 millimeter. That is because I'm going to use total 1 meter width, that is 1000 millimeter strip, divided it into two. You have to get 500 millimeter. So you must correct this data as 500 millimeter from the center. After that, I'm going to draw the column strips to X direction or layer A. To do this, it's better to select at this point and into this point. So you can draw your column strips like this. All the column strip along X direction must be drawn like this. Yes. I'm going to draw all the column strips along X direction like this. So the next step is that I'm going to draw also the column strip to Y direction. And then we are going to draw the middle strip both in X and Y direction. So it's better to change to layer B to draw the column strip to Y direction. So starting from here to the last column like this, and starting from here also to the last column like this. Sorry, draw. Okay, I'm going to draw all the column strips both in X and Y direction. After that, it's better to go to draw all the middle strips to X and Y direction. So to do this, first it's better to go to draw, draw column strips. After that, I'm going to change this to layer A. After that, column strip change to a middle strip. After this, to draw your middle strip, it's better to make it a midpoint. After that, I'm going to draw a middle strip to X direction. To do this, you can draw like this. After clicking at the middle point, okay, it's better to use that point. So the middle strip along X direction is drawn like this. So you are going to draw the middle strip along Y direction. So the only thing is that changing only the layer direction. So you can draw like this. It's so simple. I will show also how to design your flat slab using a finite element analysis method. After drawing all your design steps both in X and Y direction for column in the middle strip, it's better to go to analyze your model. So to do this, analyze your model. So first, it's better to go to check cracking analysis option. So you can use the text choice, but it's better to do everything, or it's better to left everything to the top there itself. So you can click on here. After that, make it okay. After this, you are going to run analysis and design. So yeah, it's better to save it on here. After that, the save software is going to analysis and design your flat slab. It takes some time, so we are going to wait it. Okay. Analysis and design is completed like this. From here, you are going to check two basic parameters. The first is that we are going to check the level deflection using European norm of standard, or that of Ethiopian building code of standard. From here, I'm going to check the level deflection. Go to display here. So from here, you are going to show a deformed shape. I have to select a load combination, that is a service load combination. This is because I'm going to check deflections using the serviceability limit state, or this checking of a deflection is a serviceable for a serviceability requirement. So you have to select a service load combination. After that, make it okay. From here, our maximum positive deflection is 0.09, and that of negative deflection, or the minimum deflection, is minus 3.34. So I'm going to check this within the level deflection. So European norm of standard defines the level settlement as the level settlement is equals to the maximum span length divided by 250 if you are not considering earthquake, or if you are using a normal load combinations, you can use as delta, which is equals to, that is the level deflection maximum span divided by 250. And if you are considering earthquake or the seismic situation, you can use maximum span divided by that of 500 millimeters. So you can compare this data to the actual deflection, which is the maximum 0.09, and that of minimum, which is minus 3.342. I'm going to open my calculator. A level deflection that European norm of standard defines is that maximum span, which is 6 meters. This is around here. That is the maximum span for our flat slab is 6 meters. I will show it. This is the maximum span from all the spans. So from here, I'm going to use the maximum span, that is 6 meter, which is 6,000 millimeter divided by 500. This is because I'm going to consider earthquake. So I've get 12 millimeter. So the level deflection is 12 millimeter. When we compare to the actual one, it's a minimum. So our deflection is below the level. So our defined depth is adequate to withstand this all the vertical loads. So I'm going to proceed to the next criteria that I'm going to check. So that is a punching shear. So to check the punching shear, I'm going to go to display. After this, show a punching shear design. From here, some columns have a punching shear value more than 1. I want to tell you some points regarding to punching shear. If your punching shear value is greater than 1, that means you have to increase some depths, or you have to increase a column drop panel, and if it is below a 1, that is safe. It does not need any drop panel or increasing of depths. So from here, if it is averagely around 1, or it is if it is actually at 1, that means our design is automatically, or our design is more safe and economical. So some punching shear values are around 1 and below 1, so it's economical. But columns at a to at axis a comma 4, that is this column, and the other column, that is this column, this column, this column, this have a value above 1, so it needs a drop panel. I will show later how to design drop panel and how to model it on a flat slab, and all about the reinforcement detail of drop panels. I will show it later. So I'm going to proceed to design and show all the reinforcements for this flat slab at each column and middle strips. So to do this, it's better to go to design. After that, concrete slab design. From here, it's better to go to select your design code. So go to view or revise preference. From here, have to select your design code and some parameters here. So the minimum that may be a concrete cover and other datas. So to do this, first you have to select your design code as hero code 2. So all the factors are changed like this. So you have to use the default value of hero code. So the minimum concrete cover, you can change this data to any data that you have to want. It may be TONE, the concrete covers value, but it's better to use as it is. So you can proceed to the design part. So from here, it's better to go to select all the load combination for your design. After that, go to slab or beam design. After this, start design and check. From here, go to display, show slab design. After this, you have two choices, that is your design base. I have to use first design base. I will show at the last of a tutorial, that is in tutorial 2, all about the finite element based. I will show it here in part 2. So design base, I have to use strip method for this tutorial parts. So in layer A, that means along X direction. So I have to use a unit width. So make it okay. After that, all the reinforcement values to each strips. For example, if you select a column strip here, all the negative reinforcements are shown like this, and all the positive reinforcement, that is the bottom reinforcement value, are show like this. So all the reinforcements along X direction for the column, and the bottom reinforcement is like this. And if you to change the direction, display show slab design. If you change the direction to layer B, that is to the Y direction also, all the reinforcements are given like this. So in the next tutorial part, that is tutorial part 2, I will show all about how to design these punching shear values that are failed, the section and reinforcement details of this punching shear values, that is column and drop panel. So in the third tutorial parts, using these strip values, I'm going to design, or I'm going to show how to make a detailed reinforcement detail in AutoCAD using this area of reinforcement values both in finite element and strip design methods. These were the most important parts regarding to model analysis and designs of flat slab using CSI safe version 21 software by exporting from ETABS software. I hope this video is helpful for you. Please like this video and subscribe my channel to get new updated videos daily. See you in the next important tutorial parts. Thank you for watching.